Srinivas sir? Sir, are you there? Srinivas sir?
Ah, you can start,
Sir,
sir.
sir, is my PPT visible to you?
Ah, okay. Is it visible, sir? It
Yes,
is
sir. Yes,
visible.
sir. So, good evening, sir. Good evening, the panel members. So, myself, Ravi, and here I'm presenting a presentation on my paper and with the title as Air Pollution Forecasting Using Deep Learning Algorithms. So, I am submitting this paper as a review paper, sir. So, coming to my abstraction. So, as we are living in the modern and fast world, so that day by day, the energy consumption in our daily lives is growing rapidly in an exponential way, and due to the civilization and the industrialization, and also developing the urban areas like urbanization, the emission of the automobiles and the industry exerts are growing rapidly. So these are all making making the air as the pollutant, and which is creating the harmness in the nature in a rapid way, sir. So that it is going to affect on the individual lives as well as the trees and all the living things which we are doing, which we are present in our in that particular atmosphere. So due to this, the lifespan of the humans are also going to decreases. So in this scenario, the prediction of this air pollution in our atmosphere and the way we are detecting air pollution is the rapid growth area to do the researchers, and we need to get the reliable data from regarding the air pollution by using the different kinds of methodologies, and also a logical thinking and the ecological thinking, which will be forecast the lesser air contamination, has become the fundamental and the challenging task. Because of nowadays everyone is using their own vehicles, and more people are using the so much of electricity things and etc etc. So these things is a part of increasing the what we call air pollution, so that the detecting of the air pollution in the atmosphere and the way we are detecting these things will be growing in an exponential way, sir. The future scope, which is nothing but the research scope, is increased a large. So how we are going to detect the air pollution in the environment? So that for that we are using the particulate matter. So the particulate matter is having the some kind of measurements. So if it is containing the less than the 2.5, so which is less than 2.5, which is considerable for the daily lives, but it is increasing more than 25, so that we are going to considering it as the a serious health hazards are going to happen because of this particulate matter. So most of the developed cities and most of the most populated cities are or the most urbanization cities are going to install the large amount of sensors to detect the quality of the air in the quality of the air, maybe hourly basis. So that it will we consider this one as the huge research area, so that we can do the many things by including the by including the various technologies and the algorithms to forecast the amount of particulate matter in the atmosphere. So various methods have already developed in the developed previously, and there is a lot of scope to do the research in a improved way, so that maybe the accurate results are going to produce by using the different kinds of algorithm. So what is a particulate air pollution? Basically, the air pollution can be done or can be happened in the three major sectors. The one is nothing but the a fire accident, either in a forest or the huge amount of trees where we have, so that it is going to produce a lot of carbon production, so that the air may be polluted in a rapid way. And the second one is the soil pollution also. And third one is main thing is what we call industrialization. So industrialization. So when it comes to the industrialization, industries are going to release a huge amount of chemical air when it comes to the chemical sector, and also other sectors also they are going to release a huge amount of carbonated things to the air directly, so that the huge amount of air is going to polluted in these things. So that I have mentioned the primary sources of the air pollution as well as the secondary sources of the air pollution, so that these air pollution are going to calculated based on the particulate matter. So if it is less than the 2.5, so which is not a complete harmful thing, so that the humans can live in a normal manner. If it is getting the more than 2.5, so it will be leads to the some health hazards. If it is greater than 10, so definitely that is not at all taken it as the taken by the humans or the trees wherever it is. So whoever it is, so that why, because of they are having huge amount of health hazards, so that which is not at all what we call suitable for the humans as well as the trees, animals, and etc. So in our thing, so many machine learning algorithms are going to use it to predict the air pollution in the atmosphere. So we try to develop so many techniques have used. So we try to develop by using the deep learning techniques as well as the artificial neural network techniques. So in this, we mainly use the four different kinds of techniques like recurrent neural network and long short term memory, as well as bidirectional LSTM, and last one is the deep belief network. So that by using these kind of techniques, so there is a huge scope to get the efficient results for detecting the air pollution in the particular atmosphere. So already so much of research work has done regarding the detection of the air pollution. In this, I have placed the few different research things in my presentation. The first one is the by and the team have done the research on the performing an analysis for three air pollution episodes in the Pearl River Delta region. So at the after their research, they have found the conclusion they have obtained the better forecasting performance when comes compared to the mono BPNN model, and have and has they are having some kind of limitations. So those are not, they are still planning to get more accurate results by pre-processing and lead to some basic bias conditions. So those are the limitations in the first research work. So that the next we have seen that see that Lee and the team have done the some dynamic sim research regarding the dynamic symbols, deculter map, mashup layer, and multi granularity time series visualization for the thematic mapping. And they have done their work in the rapid growth way, and they have concluded the results as they may be get the some validating things for the air quality trend. Yes, in this also they are having the some kind of limitations, and there is a scope of future work. So that one more research work have done regarding the this air pollution detecting system by Wang and their team. So they are suggested a two-phase document decomposition technique and modifying extreme learning machine for air quality indexing forecasting. So by their research, they have find some kind of conclusion like their simulated results shows that presented model gives higher forecast accuracy. And of course, in this also they are having some limitations, or else there is a scope of future work, and it will be continued by the another one. And the another research work again Wang have done with their team regarding the air quality time series of forecasting. So here also they have some kind involved or developed by using the a few different kinds of algorithms. So they have invented that particulator matter as the they have taken the particulator matter value as the 2.5 by using the SVM and the aroma model. And they have concluded that they have proposed the hybrid model for based on the linear and non-linear model generates the more reliable and accurate forecast capability, and they have released or they have left with some future scope to find out the other pollutants are not included. Other pollutants are not included, so that they are not considered, and they have done this. And the another research work has happened by the team Vacantis and team. So they have performed some research on environmental parameter of interest have been forecast the concentration levels. So these in this particular what we call the research area, they have taken the upper bound limit and the lower bound limit for the particulator matter. The upper bound limit has taken as the 10, and the lower bound value taken as the 2.5, and they are using the artificial neural network and the machine learning things to develop the some kind of forecasting things. So, and here the concluded as the advantages adopt to the data set of the AQI, and of course they have left some kind of future work. They are not capable of resolving strongly nonlinear relationships. So based this is the few different research work have done to find out the air pollution in the atmosphere. They have used the few different kinds of models, and we want to overcome all these limitations by doing by doing the research by applying the deep learning techniques. And coming to the my presentation conclusion, basically what we think is the air pollution is only because of CO2 and the NO2 and etc etc. But the way we are finding out the air pollution in the atmosphere is based on the particulate matter. So, and the particulate matter is also having the some kind of limitations, so that
Ravi,
may, so that maybe the
Ravi,
value.
sorry for interrupting you.
Sir.
Because I have interrupted because you came to the conclusion slide.
Yes, sir.
You have not shown any results in this presentation.
Sir, actually, we are still presenting it as the review paper only, sir, because of we are doing things in a better format, sir, so that we have seen the things, and we try to overcome the disadvantages and the limitations in the existing work.
So you have not yet done any work on this. This is a review paper, right?
Yes, sir. Yes, sir. Yes, sir.
Only review paper, but still
Yes,
you
sir.
can compare the results, right?
Yes, sir.
Yeah. Okay, it's okay. Conclude.
Yes, yeah, sure, sir. So these are the few things that we are considering to get the better results, like LSTM, as well as the CNN and DNN things. So maybe it will be helpful to the nature as well as the humans to boost their uh, the what we call the living range. And these are the few references that we have seen for doing this particular research works. So already so much of work have done by using the neural network, machine learning, and artificial intelligence things. We try to do we try to do the things by using the deep learning techniques, and mainly LSTM and the recurrent neural network by using those things. Thank you. Thank you for the presentation, giving me this opportunity.
Thank you, Ravi. So before that, sorry for the interruption.
Sir.
Today our session one chair, Dr. Ravikumar Varmagaru. Sir, welcome
Yes,
to the
sir.
presentation.
Yes, sir.
He is the HOD of CS department from
Yes, sir.
Engineering College. Sir, welcome to presentation technical session one, sir. Artificial intelligence and applications.
Yeah, thank you, sir. Yeah.
Okay.
So the next paper.
So
next paper
thank
ID
you for the
7.
opportunity.
Paper ID 7. Paper ID 7. Dakshyani Himabindu. Next paper ID 18. C. Ramakrishna, a novel approach of deep neural network performance analysis for predicting chronic kidney disease. Are you there, sir? Maybe give the presentation. Please let me know. Ravi sir, please close our chart.
Yeah, sir. Thank you.
C. Ramakrishna garu. C. Ramakrishna garu. Are you ready to give the presentation? Sir, you are there here. C. Ramakrishna garu.
Yeah. Yes, sir. Sir, my another author will give. Good evening,
Okay,
sir.
okay.
My another
Okay.
author will give. Ranjit is there, sir. So he will.
Okay.
He will join.
Okay. Share your PPT, sir.
1 second, sir. 1 second, sir. Ranjit will join, sir.
For your paper ID?
Sir, for paper ID is 018, sir. He will give. He will give, sir.
Okay.
Just wait.
Hello, sir. Hello, sir. According to given timing, sir, this is Kantaraju 118, sir. Now my presentation time is 6:45 to 7, sir. Is it correct or not, sir?
No problem, sir. You can carry on. You can present now.
Oh, okay, sir. Thank you, sir.
Just share your PPT.
Okay, sir. Okay, sir.
The next paper ID 20. Be ready with the presentation. 21. I think same author, C. Ramakrishna garu.
Yes, sir. Paper ID 8920 is joined, sir. Just now.
Okay, sir.
Ranjit will give, sir. He joined.
Okay, sir. Okay. Sir, Ranjit sir, open it in a full screen mode, sir. Press F5.
Sir, this is Ramakrishna, sir. This is actually not Ranjit.
Okay.
Our paper ID is 018 and 020 021, sir. But here the paper ID 113. But this schedule 113 is not there now, sir.
Sir, 113 he is not there, sir. Here the for same Ramakrishna paper ID is 21.
Yeah.
And 18 and 20.
But paper ID 113 sharing someone, sir. This is not actually.
No, sir. Here today's session only for these IDs, sir.
Yes, sir. But 113
Ramakrishna is here. I think he's ready.
Yeah. Yes, sir. I'm ready, sir. And my
Yeah,
another
please
author,
start your
is-
paper, sir. Ramakrishna gar,
sir.
please start your your paper,
Okay.
your presentation. Which paper you are
Okay.
going to start? 18?
No, sir.
Not 18, sir. Sir, Ravikiran sir, actually he is saying that 113 is not in the session 1. That belongs to one more session, sir.
No. That we cannot allow here.
Yeah, only in that whatever the paper IDs I have already sent in that group, those IDs I will allow, sir.
Yeah.
Ramakrishna garu.
18, 20, 21.
Sir.
Yes, sir.
Because sessions are already scheduled and communicated to the authors.
Yes, sir.
Any change, I think you need to take pre-approval from the concerned authorities.
No, sir. One second, sir. Hello, sir.
Sir, is it a technical session too, sir?
Yeah. Sir, some technical problem is there. Screen is not sharing, sir, here. So that's why he is facing some problem. Ranjit, 018 and 020. Anyway, I will give the 021 presentation, sir, right now. Shall I continue?
Okay. You can.
Yeah. I'll continue 021, sir.
Yes.
Yes.
You can start 21. Meanwhile, I think he will be ready with 18.
Yes, sir.
Because all the three papers, you are the common author.
Yes, sir. I'm the common. So I'm sharing. I'm giving 21, sir.
Okay.
So my screen is visible to you, sir. Sir, my
Not
screen.
clear, sir. Not clear.
My screen is not clear, sir.
Oh.
Yeah, wait, sir.
Just open our PPT, sir.
Yeah,
Open.
yes. Now it visible, sir?
No, sir. So, better to ask your co-authors. They will show the presentation. You just explain the PPT, sir. I think some problem is there with you.
Some problem is there, sir. Sir, here I'm sharing one thing, sir. Here I'm sharing. One second. Sir, your entire screen, a window, a tab. Here I'm showing, sir. So I'm clicking here, entire screen. Right. Click on here and
Okay, move back to your PPT. You are still in the tab 2. I think you are open 3 tabs, right?
yes, sir. Yeah, 3 tabs, right? Yes, sir. Yes, sir.
Okay. Move back to your PPT. Yes, it is open. Open it.
Yes.
Yes,
Now
that's it.
visible, sir? No, it.
Visible. Press maximize the screen, sir. Press
Yeah,
F5.
yes, 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 sir. Yeah. Good evening, everybody.
Okay.
Myself,
Carry on.
myself, C. Ramakrishna, and my co-authors are Pradeep Reddy and Venkatesh. So here, my title is Design and Evaluation of Plant Leaf Disease Detection based on the CNN classification systems. So we are myself and Pradeep Reddy we are CMR Institute of Technology, Hyderabad, and Venkatesh is the SR University. SR University Warangal, sir. So here I'm moving. So my title is Design and Evaluation of Plant Leaf Disease Detection based on the CN classification system. Here in agricultural growth, there is a requirement detection to plant leaves starting stage. So here in our country, India, most of the people are depend upon the agriculture only. So, but here there is a drawback is the plants and leaves are detected by the diseases. So here we in this paper we need to use some techniques. So that is for example CNN convolutional neural network classification system we use to accurate and reliable system what this is detected in the leaves. So here the abstract. Sir.
One second. Your PPT is not visible, sir.
No, not visible, sir.
Yes.
In previous slide.
No, sir. Still, I think you are open in your mail ID. It shows your mails.
Mail, no, sir.
I think you have 2 accounts, sir. Just check it here.
Oh, sir. Now it is open.
No.
Now it is
one
not.
more. I think you are from the 2 accounts. Just open that one. One more, sir. Close all those things, sir.
No, it is visible. It is visible.
No.
Right, sir. Just I'll open. Now my screen is visible, sir.
No, sir.
No, not visible still.
Just open it.
Yeah. I'm downloading and open. I'll open. No, sir.
Maximize it, sir.
Right, maximize. Now it is visible, sir. Okay, sir. Hello.
No, sir.
Not visible, sir.
Not visible.
Pardon?
Sir, Kiran, sir, is it visible to you, sir?
No. He is in the meeting, sir. Actually, he has to click on the presentation.
Yes, I think he has maintained two accounts, sir. One is presentation account, one is itself his own account. That is the main problem.
Yes, sir. No, sir. One second.
Just open your PPT, sir. Next one. Yeah, that one.
Yep.
Yes.
Yes.
Just maximize it. That's it. Just carry on that one only.
Okay, sir.
Okay.
Right, sir. Now it will, sir.
Yeah, visible, sir. Carry on.
Right.
Yes,
So
yes.
then-
So we lost some time. You need to speed up. Okay.
Okay. Sure.
Yeah.
So here abstract is here we are using the K-means clustering algorithm and gray level co-occurrence matrix, and for future extraction are used. The leaf is detected. The disease detected depend on CNN presented in this paper. Compare with the existing methods and parameters in the results analysis. Here we are using the gray level co-occurrent matrix. So what is mean by gray level co-occurrent matrix means? So here we are using the computed correlation for image classification leaf segment image. So here the leaf will be divided into segmentation, different segmentation, and we will be extract that particular leaf. Okay, sir. So here we are using the keywords leaf disease detection and gray level co-occurrence matrix and K-means classification algorithm and convolutional neural networks. These are the keywords we are using. So introduction is the most important sector in India, sir. There are 80% of the people are depends on the agriculture only, sir. So here the most of the people are we survey the various types of vegetables like fruits, fruit leaves, and we detect some diseases on that fruit leaves. So many farmers are poor. Why? Because there are diseases from the leaves. So that's why we invented we use some algorithm to detect the diseases in the leaf. So for example, mainly here vegetables and fruits are common items in the agriculture things. They are commonly our Indians are vegetables and fruits are they will be allowed, sir. So here we are using the convolutional neural network in image processing. Here a system which like human brain neurons is a computation model. Each neuron requires the input as an input, perform different operations, produce the output to the another neuron. Because here in convolutional neural network, one neuron is take as an input, and that neuron will be produce the output. That output will be take the another neuron as an input. So here this is the convolutional neural network, sir. So here we can image classification and image automatic analysis are different applications of image processing. It consists of various techniques such as CNN and RNN, that is recurrence neural network, sir. So here the recurrent neural network is the artificial neural networks which is used to sequential data or time series data. So RNN means recurrence neural networks. It will find the sequence of neuron data, sir. And LSTM means long short-term memory, etc. Here the general block diagram of a CNN is shown that perform the classification of images of vegetables and fruit leaves. So here the classification images is done two ways. One is testing and another one is training. There are two ways we will classification images. First is testing, another one is the training, sir. So here leaf disease detection based on the convolution CNN. In this technique, we present the paper. Main aim of the identify diseases of the plants while observing the leaves. So if we want to before observing the leaves, we will observe the plants first, right? After that, we here the method provide disease types that can affect the leaf by using image process techniques which find the reason disease on the leaf. This proposed system deals with prediction of the plant. This is with the help K-means clustering algorithm, segmentation algorithm, and GLCM based future and extraction. So the K-means algorithm means it is the unsupervised learning algorithm, sir, which groups unable to data sets and different clusters. So K-means algorithm, K-means clustering algorithm, it will be divided into groups, different clusters, right? For example, K, for example, here the K value is 2, that cluster, there are 2 clusters. If the K value is 3, there are 3 clusters. So that will be divided into clusters. Here the accuracy and affected area can be provided with the listed. So we using these k-means algorithm, the accuracy we will give the within less time to the disease leaf. So leaf disease detection based on the CNN. So here, first one is the input images. The plant images will be taken as an input for database and compare with the data sets and images are stored and considered. First, we take the one input plant image and we compare with the data sets, whatever we already stored in our system. Next, pre-processing means here to reduce the noise and remove the blur from the image and improve the image, and filters are applied the leaf in pre-processing steps. So here we reduce the blur image. If the image is blur, it will be reduced. Next, another one is color transformation. The numerous bits with the data or color image parameter processing. Color images is done directly and which may reduce the velocity computation. Next, image segmentation. A conversion of digital image in segment is done by technique image segmentation, which makes easily analysis. Image segmentation means we will divide the images into different segment, and we can easily analysis. Right, sir? Now, feature extraction is here. The feature extraction is the important step for the recognition of image, which is done by GLCM and DWT. So GLCM is a matrix, a gray level co-occurrence matrix, where the number of rows and columns are equal to the number of gray levels. So nothing but extracting statistical measures from the matrix. And what is DWT means here? Data wavelet transformation. So here it provides the simultaneous spatial and frequency domain information of the image. So these will be the feature extraction of the disease leaf. So GLCM, gray level co-occurrence matrix, is extract the various texture features like homogeneity, entropy, correlation, contraction, energy. So one dimensional and second order GLCM are the different implementation of GLCM. In addition to the color space, these implementations of GLCM were applied co-occurrence matrix. So these GLCM is the main important to find the disease of the leaf. So here the image made, we took the picture and the pixels, each pixel has its intensity levels. So the GLCM classify the segments of the leaf or leaf image based on the different luminous levels. So GLCM classify the segments. So that is the different luminous levels. So here another convolution neural networks, the CNN algorithm hierarchical based feature extraction method used to approach the pixel value mapping and then evaluate the trained image data sets. So already trained images are stored in our system. Then we will mapping with the actual diseases systems. So here the results, the graphical user interface designed to detect the diseases automatically using the leaf picture. So here we use the GUI and automatically leaf picture, it will detect the leaf picture. So here, based on the different patterns, infected regions of the leaf image classify the diseases. It is also calculate the infected area.
Where are the results? Where are the results?
Sir, coming, sir. Wait.
Yes,
here. So this is the result, sir. So this is the original image we took, and we will use a GLCM algorithm. Then we'll clusters. The cluster 1, cluster 2, cluster 3. The image will be divided into different segments. So this is the original image, and these are the segments of that particular image, sir. So here the GUI is automatically find out the some bacterial blast and healthy leaf and alternate anthracnose. So these are the leaves that the graphical user interface is automatically find out. So here for calculating the percentage of disease with how much the leaf affected. So here we calculated disease area cluster object is selected. Let us assume, for example, X is a disease area and Y
Okay,
is
go to the next slide.
right. Now conclusion is the system is used for the different images for detecting diseases in a leaf proposal. This system has had used different techniques such as k-means clustering and GLCM based on feature extraction method and CNN classified detect as well as classify various disease type. So here we use the RGB pre-processing stage is the RGB image to reduce the paddy leaves. The RGB is converted into grayscale to HSV model. The hierarchical feature of extraction is carried out by using CNN in the proposed method, which can be map pixel intensity input. So here some data sets, V sets. Here the data sets contain the various diseases affected leaves, image such as Sarcospia leaf spot affected, bacterial blight affected, anthracene and alternate affected leaf images. So we will compare with that this type of leaves, and our main aim of this is the area of effect plus a percentage to propose some system result has high accuracy. So the system is presented this paper as the accuracy is 98.05 of accuracy. We will find out the leaf will be how much will disease the leaf will be affected with the diseases, right, sir? So here we are taking the references, some transfer learning for image segmentation by combining image weighting and kernel learning, IEEE transaction paper, and some real-time detection of apple leaf diseases using deep learning approach based on improved convolution detection neural networks, IEEE, sir. So these are the other differences, sir. New secret sharing scheme based on the faster or CNN image retrieval. So another one is volumetric object recognizing object 3D.
Okay, Ramakrishna.
Right, sir.
Okay, what is the
Okay, sir.
pre-processing? You have told
thank you,
that
sir.
in the pre-processing stage,
Yes, sir.
you have used some filters. Can you tell me the filters? What filters you have used in the pre-processing?
Yes, sir.
So what are the filters you are used in our work, sir? Sari is asking about filters. So tell me the filters. Which filters you are used in your pre-processing in that step, sir?
In that DWT, sir, discrete wavelet transformation filter.
No, that is for feature extraction, right?
Yes, sir. Sir.
It's okay. You can carry on with the. So you want to carry on with the next presentation, next paper?
Ranjit will continue, sir.
Yeah, please.
Sir. Yes.
Ranjit, carry.
Sir.
Right.
Okay, it is visible, sir.
Yes.
Okay,
Put
sir.
your.
Good evening, sir. Good evening, everyone.
Yes.
Myself, R. Ravikumar. Okay. This is my paper ID 18 in a novel approach of deep neural network performance analysis for predicting chronic kidney disease. Okay. First of all, chronic kidney disease enters slowly into human body, but it lasts for a long period after getting affected by the. Sir,
You are not able to listen. Make it full screen.
Okay, sir. Sir, now it's okay. Sir,
Press F5, sir. Press
now it's
F5.
visible?
Otherwise, below, just check it here, sir. Full screen option
sir.
is there. Yes, it's visible. Just check with it, sir. Oh.
Sir, 1 minute. Sir, now it's okay. Sir,
It's okay. Just maximize it, sir. Just press F5. Oh my God. Sir Ranjit sir. Sir, hello, Ranjit sir. Are you getting my voice? Hello? Ranjit sir? One is presenting. Ramakrishna sir, please share my information to Ranjit sir. I think some problem is there.
Yes, sir. I'm calling, sir.
Ramakrishna sir, what about the another? What about the third paper?
Ranjit only, sir. Hello, Ranjit. Hello. Yeah.
sir. F5,
Ranjit sir, again open it. I will guide you how to maximize the screen. Just open it again.
Ranjit, share the screen.
Sir. Share it. Student.
Sir Ranjit sir, just I will guide you. So below, just check it here. 92% there is right. Ranjit sir. Ranjit Kumar garu.
Sir. Sir.
Beside 92%, one small icon is there, right? Just click that icon. Below, sir, bottom. Beside 92, just side.
Sir, in the PowerPoint application,
Okay.
bottom line, right side, you can see three buttons, three icons you can see.
Below, sir, below.
Click the third icon on the
Ranjit,
PowerPoint presentation.
3 dots are 3 dots lo.
Yes, side. Third one. No, sir. 99, I think 90. Yes,
on
side.
the PowerPoint application.
Next, sir. Next one.
Dani pakkadi, right side.
Sir,
Third
not
one.
middle,
You have
sir.
to look at the
Not
second
middle
one.
one, sir. Third one.
Third one.
This one.
Third one, sir. Third one. I think you pressed the second one, middle.
Design only. Slide show, okay. Ah, okay.
From beginning. Click on from beginning. Slideshow from beginning. First one.
Yes.
Ah, sir. Ah, okay.
That one.
Okay. Ah. Okay, sir. Now it's visible, sir. Hello.
Can you start from beginning?
Okay, sir. Carry on. Please start
Okay,
your
no
presentation.
problem.
It's already late.
Okay, sir. Okay. So this is my topic, a novel approach of deep neural network performance analysis for predicting chronic kidney disease. So chronic kidney disease enters slowly into human body, but it lasts for a long period after getting affected the disease. Okay, this chronic disease cannot be completely erected by applying mechanisms like artificial filtering, such as dialysis or by kidneys replacement. Okay, this is not the solution. Okay, this chronic kidney disease is deadly disease which shows its intense reaction in the ending stages. Okay, slowly it will affect into our human body. So this chronic disease is a deadly disease which shows its intense reaction in the ending stages. That's why chronic kidney disease identification in early stage is very required to provide necessary treatment for prevention or cure of such deadly disease. Okay, early detection of chronic kidney disease helps the patients and doctors to take appropriate care and treatment measure to cut down further consequences and progress of disease. Okay, by using machine in healthcare sector, the pathological data of patient disease can be classified and predicted. Okay, here majorly we can use these type of keywords that are k-neighbor algorithm, k-net. Next, support vector machine learning, chronic kidney disease. Okay, chronic kidney disease stage identification. These are the major keywords are used in our paper. Next, introduction. In most of the countries having medium or low earning people, this
Sir,
chronic
Manjeet
kidney, sir.
Your slides are not moving, sir. You are in this and the still on the first slide, sir. Just move.
Okay, sir. Okay. So here, machine learning algorithms are used for prediction of
Sir,
kidney
move
disease.
back. Sir, move to the slide. Move to the introduction slide. You are in the still in the first slide.
So machine learning algorithms are used for predicting of kidney disease. Okay, the chronic kidney disease can be identified using ensemble learners. Okay, and individual performance. Here,
Sir, Ranjit sir,
kidney
still
transplant.
same problem, sir. You are still.
Wait.
You are still in the first slide.
Wait, sir.
Yes. Oh. Just operate it and explain it.
I think, sir, this is the first time he is giving a presentation.
Yes. That is the problem, sir.
Yes, sir.
Okay, just go to
Just
the results.
explain and move the slides, sir, one by one.
Go to the results. Just
So,
skip this literature.
Okay.
Go to the results, sir, please.
Sir?
So move to the result slide, sir. Result slide. What are the outputs you are getting?
Okay,
Just move to that slide, sir.
So this is the data, sir. This is the data. So with the help of data mining techniques, these are the techniques we are used in this paper. Okay, these are the techniques: SVM, support vector machine, and K nearest neighbor. Next, boot and DNN algorithms are compared for their efficiency in detection of kidney disease with high accuracy values. Okay, so
Okay, go
ADA
to the
boost,
results, sir. Go to the results. Go to the results. Next. Next.
sir, this is the result.
Okay, show
So
the results, sir. Results.
mainly we focus on accuracy,
Next.
precision, recall.
Next. Okay.
So these are the techniques we are used in this paper, sir. Small vector machine, K nearest neighbor algorithm, RF algorithm, ADA boost algorithm, XG boost algorithm, DNN classification algorithm. Okay.
Sir,
In
what is SVM? Full form of SVM?
Sir,
Small vector machine. Huh? What is the full form of SVM?
support vector machine, sir.
Okay. Okay.
Support vector machine, sir.
What is your data set size, sir? What is your data set size?
Actually, minimum size is 20, sir. Max we can take up to 2000 values, sir. Minimum starting is 20.
Okay, sir. You can conclude. You can go to the next paper.
Okay.
Ranjit sir, you just conclude it, sir. Your presentation.
Sir. Okay, sir. So this is a conclusion, sir. The raw data is collected from UCI machine learning library about chronic kidney disease patient. Such data set is processed by data mining process through filtration process for filtration process of future selection, such as univariate selection and correlation matrix. These are the two major techniques. Okay, first one is univariate selection and second one is correlation matrix to identify the best features of the data set. So the main objective of this paper is classification and identification of chronic kidney disease patients. Okay, this study represents the DNN, which is machine learning algorithm, is provided to be best algorithm in terms of accuracy, precision, and recall attributes, sir.
Okay, sir.
Okay, sir. Sir, Ramakrishna sir, one more paper is also there from your end. I think 21. Who are going to present that particular paper, sir? Ramakrishna sir.
Sir, 21 is completed, sir.
20, I think 20. Taxonomy of Intrusion.
20. Ranjit? Hello? Ranjit? I'll share the screen. You present, okay?
Okay, sir.
We are facing some problems, right? Now start, Ranjit. Sir, it is easy to be visible, sir?
Yes,
yes,
visible, sir. Carry on.
Ranjit, now you can start, Ranjit.
Okay, sir. So,
I will share this.
good evening, sir. One more paper ID is 20. The paper title is Taxonomy of Intrusion Detection and its Effectiveness in Internet of Things. So, the paper aim is intrusion detection system provide the defense against cyber attacks in the distributed systems. In this paper, the researchers belongs to the intruder detection techniques for the in IoT and efficiency. These are the major two techniques. Okay, here intrusion detections are classified into two categories. One is anomaly detection and second one is signature detection. Here, the specification detection method belongs to anomaly detection based on the rule generating technique. From this study, okay, the research of anomaly detection technique is having notable privacy technique compared to signature technique. The random forest rule generation method has the high privacy and is much efficient in these IDs. IoT devices are usually resource constrained devices and this in turn require lightweight methods for privacy protection. The future selection method such as weighted search algorithm as a higher detection value in the IDs. Here, majorly, we are used some keywords in this paper that are anomaly detection, search algorithm, Internet of Things, intruder detection technique, and random forest signature detection specification techniques. These are the major keywords are used in this paper. So, first introduction of taxonomy of intrusion detection and its effectiveness in Internet of Things. Here, Internet of Things allows physically objects to be connected to the internet, turning them into smart objects that are uniquely identifiable through various sensors. Okay, this interconnection also enables object to transfer data over a network with reduced human intervention. Information has become a valuable resource in modern society. So, next, intrusion detections are able to rectify malicious behavior in a network by analyzing IoT traffic in real time. On detecting an attack, system helps to take measure to protect the system from damage. So, next overview of IoT. IoT service platform, each application needs to know how to access heterogeneous IoT middleware and which IoT resources should be accessed. As more and more devices are using the internet to transfer information and these are called smart devices. For instance, smart devices are attached with sensors like motion sensor, gas, electric meters, and many other type of sensors. So this is the diagram. IoT video surveillance in stadium. Okay, this is the cloud. IoT gateway. Okay, here sensors are accessed various resources from the cloud. Next, intrusion detection. And intrusion detection systems is a technique is used to detect the attack in the system by analyzing the activeness in the network. If IDs identify any abnormal activity in the network, then it creates an alarm to the user to our network security team to analyze security flaw in the network. These are two major categories in the IDs, namely signature-based or anomaly-based detection system. Here, first one is signature-based detection method involves in matching the current behavior of the network with
Okay, sir,
the.
please go to the next slide. Next slide.
Right.
So, anomaly detection. Anomaly detection is the key element.
Okay, next slide. What is your work, sir? Please tell me about your work. This is all the basic theory part. What is your work? Next. Do you have any results? Did you use any data for this?
Yes, sir. Yes, sir. Sir, Ramakrishna sir, go to the next slide. So this is the result, sir. Sir, go to previous slide. This is the result, sir.
Where are the results, sir? Where are the results? You are showing the formulas and you are telling that is the result. What data set you have used? What algorithms you have used? What is the result?
Sir, in this paper only we can use IoT instruments, sir. Mainly intrusion detection and its effectiveness. Some keywords, mainly anomalies detection and search algorithms.
Okay. Are there any results? No results.
Show me the results, sir. What you are getting in our project, in our work. So this is all the formulas, sir. Generally, we are using for what
Okay,
confusion
sir.
matrix, sir.
Okay, sir. Just conclude, sir. We can just, sir. Next paper, sir.
Okay,
Sir.
sir,
Okay,
conclude it.
you can leave. You can leave, sir.
Okay, sir.
The next one, paper ID 46, 47.
Yes, sir. For paper ID 47.
Okay. So share your screen, sir.
Yes, sir.
47, right?
Sir, is it visible, sir?
Yes.
Hello.
Visible, sir. Visible.
Good evening, everyone. Myself, Palacharla Ravikumar. Today I'm going to present a novel method for text classification using feature selection algorithm and term weight measures. This is the outline introduction to text classification and what are the data sets I used.
Sir, you are the single author for this paper?
No, sir, two others, sir.
Okay.
But you
no,
mentioned only one.
Just can I see the names of the authors in the first slide?
Yeah, I am the first author, sir, Palacharla Ravikumar.
Okay.
And second author is Dr. V. Valikumari.
So you have to mention the names, sir, author names in your presentation also. Okay.
Okay, sir. Okay, sir.
Okay, carry on.
What are the data sets I used in this text classification? And what are the measures I used for calculating the performance of my text classification methods, literature survey, problem statement, and my proposed methodologies, conclusion, and future score. So first thing is what I motivated here to implement this methods. One is the text classification problem is everywhere. And in this text classification, there is a high dimensionality problem. There are so many features out there. Out of that features, we need to select the best relevant feature for classifying the text. And another thing I motivated here is to find out the importance of a term in the document representation. The term importance is very, very important to represent the document. So these three I motivated for me to implement the proposed method. The first objective of this method is selecting the maximal discriminative capability features and eliminating the redundant features for text classification. This is my first objective, to find out the features that feature should have the high discriminative capability feature and should eliminate the redundant features. So for this, I propose a method. I developed a novel filter-based multivariant feature selection technique, CFDRI. I named it as the CFDRI to identify the important features from the text classification from the corpus of documents. And these set of features will be used for to compute the further calculating the importance of the document. And my second objective is to determine the importance of a term in the document representation. For this, I developed a new proposition method, that is a new term weight measure, TF, NRF, IPN, DF, PN, DDF, to compute the value of a term in the vector representation. And my third objective is to improve and attain best accuracies for the text classification on different data sets. For this, I combined my earlier two proposed methods, that is CFDRI and another proposed new term weight measure. I combined these two proposed methods for getting for attaining the best accuracies for text classifications. Coming to the introduction part regarding the text classification, it is a technique of assigning the known class label to the unknown textual documents. So these techniques are used in various applications such as sentiment analysis, authorship analysis, fake news detection, spam email. So in everywhere, in various applications, we can use these techniques. So in this text classification process, the words in the documents are considered as the features. So in there will be some huge amounts of corpus of documents. So we'll take each document will be considered, and in each document, there will be so many words that will be treated as the features, or we can also call it as a term. So this word is will be considered as the features. So the most important words which are having more differentiating power are considered in the representation of the document. That means there are so many features available in the text classification. That means so many words are available in the text classification. But out of these words, we need to select the best word which is having the high discriminating power, so that we can easily classify the text. So that word we need to identify. Identification of such words or features is the primary step in the classification process. So, and there is one more issue here in this text classification is high dimensionality. So let us say if you take one document, in that document there will be so many thousands of words will be available. So if you consider all the thousands of words, it will become more complex, and it is a time taking process. So that is why we need to reduce that dimensionality. So only the words which are very relevant to classify the text, only those words we need to consider, and we need to remove the redundancy. So this is the main objective for my proposed method. Coming to this, this is existing BOW model. BOW means bag of words. Here, let us say, take an example like document 1. John likes to watch movies. Mary likes movies too. And if you take another document, so here first we'll consider all the words that are in all the available in all the documents. So that will be placed in a list of indexes. And we need to convert this list of words into the vector representation. So here in document 1 representation is just we are using the frequency of the word in a sentence. For example, let us say John. In document 1, John repeats only one time, so the value is here 1. And likes repeats 2 times, means here 2. This is a vector representation. Actually, this is the standard model, but here instead of in my proposed method, instead of taking this frequency of the words, here I am computing the relevant score for each term to classify the text. That is my main objective. Why I proposed the new method for classifying the text. Sir, excuse me, sir, are you able to hear my voice properly, sir?
Yes,
Carry on.
continue.
Yes. So this is a standard model. So the same thing, the same method I implemented in my proposed method, but instead of taking the frequency of the words that appear in the document, here I'll compute the relevant score for each term. So, and it will represent like, for example, if you take 1,000 words, so each word, here they taken as the frequency of each word in the document, but here instead of taking the frequency, I'm calculating the score for the particular word. And this is the data set characteristics. These are the data sets I use, various data sets I used to implement my proportion method. Number of number of instances 200. This is the hate speech spreaders. This data set, this contains number of classes is only 2 different classes are there, and it contains 200 tweets in each instance. That means in each row it contains 200 tweets. We consider all 200 tweets as one document. And fake news detection, number of classes is 2. Here there are 25,200 documents are there, fake and real news data set. And IMDb, this is a movie data set. 50,000 records are there, 50,000 documents are there, not records. Each record contain one document. Each record contain one document. Like that, 50,000 documents are considered here. And 20 news group, AG news dataset. All these are the news related to the news datasets. I included all these datasets, and I experimented my proposed method by considering all these datasets. These are the evaluation measures for calculating the accuracy, for calculating the performance of my proposed method. And this is a problem statement: analysis and construction of new models for classifying the text by using future selection algorithms and term weight methods. This is my problem statement. I want to propose a new model for classifying the text by using the future selection algorithm. There are so many future selection algorithms exist, and term weight methods also exist. This is the proposed methodology. So first I will take the data set, what I explained in the previous slide about the data sets, and apply suitable pre-processing techniques. Here pre-processing technique means just I will remove I'll clean the data, like I will remove the null values like this, and I will also remove the stop words, and I'll do some stemming technique also. Stop words means if you take a document, in that document there will be words like is, or, the. Those words are not they don't have any discriminating power for the document. Those words are common in if you take any set of documents, in all the documents those words are common. So I'll remove those words. Those words we call it as the stop words. So at beginning only we will predefine those stop words in a list, and I will exclude those stop words in my analysis. And after that I will apply the stemming. Stemming means, for example, same meaning but in different form, like for example, clean, cleaning, cleanliness. All these will have the same meaning, but it will be in a different form. So I'll convert all these into one stem, one root. So that will be applied on these data sets. Then I will apply the future selection algorithm based approach, and I will represent in the document vector. Then I will apply the machine learning algorithm. This is one method. And this another method is by using the existing future selection algorithm, I am proposing a new term weight measure here. And again, using the old vector representation, I am applying the machine. I am checking the accuracy here. And finally, I'm not using any existing methods here. I'm using my proposed future selection algorithm and proposed term weight measure for representing the documents, and I'll apply the I'll train those data sets by using these algorithms, and I'll compare the accuracy with the existing methods. So this is my entire proposed methodology. So the first methodology is
just time up. You can just show the results and conclude.
Sir. So this is the standard model, sir. This is the standard diagram here. Instead of taking the frequency here, I implemented my proposed method. So just these are the existing future selection algorithms, information gain, chi-square, mutual information. So this is my proposed method here. So I included various. This is a category distribution. That means I included various categories here to represent this proposed method, like consider the information of term distribution in positive clauses, how the term is distributed in the negative clause of documents, and how the term occurs in a whole corpus of documents. So I included all the categories. So here, this
What is TF here?
TFI is the term frequency. For example, I want to calculate the score for a particular term. So if TFI means what is the frequency of the term in that in the entire data set.
Okay.
And here this is a proportionate of the occurrence of the term in the positive class of documents, and proportionate of the term in the positive class documents, and not T1, and here FTI comma POS means here again I'm taking the frequency of a particular term in the positive class of documents. So like that I'm considering various different categories, and I'm increasing the score of the particular term. Now actually my objective is to remove the redundancy. So for removing the redundancy, I'm subtracting the correlation. First I'll find the correlation between the term 1 and term 2, and I will, if the correlation is high, means there the redundancy is there. So I want to remove the redundancy. If the correlation is high between TI and TJ, means we need to remove that redundancy. So I'm subtracting that correlation so that the score will be the score will be increased. So in that way, I'll calculate the relevant score for each term. So this is the analysis of the proposed method. Term frequency of T1 in total documents is 2. Let us say there are 100 documents, 50 for positive class of documents and 50 negative class of documents. If term frequency of T1 in total documents is 240 and term frequency of T2 in total documents is 150, then here T1 has more weight. Why? Because the term frequency is more. The T1 contains a more number of documents compared to the term 2. So that is why T1 is having the more weight. So I'm calculating all these weights here. The next one is log PC, positive class of proportionate. The term occurs in the positive class of documents. In how many number of documents the term occurs. For example, there are 1000 positive class documents and total 2000. Out of 2000, 1000 documents are positive and thousands are negative. And in 1000 positive class of documents, only in 300 documents only the term occurs. So if I substitute in this formula, I got the value 1.6. And let us consider another example, T2. If T2 is having T2,
just conclude. Time up actually. Please just show the results and conclude. Just 1 or 2 minutes. You have only 1 minute.
Yes, sir. Yes, sir. Okay, sir. So this is one method, sir. And I'm having one more method, that is a term weight measure.
Okay,
so,
just show the results.
Yes,
the
sir.
results. Just
Yes,
show
sir.
the comparison between the two methods if you have.
No, sir. This is not the comparison, sir. Here,
Okay,
these are the two different methods. This is my proposed term weight measure, sir.
Okay.
And these are my analysis why I included these factors in my term weight measure, so that to improve the relevant score of a particular term. And the same example I forwarded in the existing term weight measures. So I got the better results only compared to these are my results, sir. So these are the accuracies of term weight measures based approach. So here I used 6 machine learning algorithms. KNN, NBM, logistic regression, SVM, decision tree, random forest, and I applied these algorithms on various data sets like HSS, fake news detection, IMDb. These are the 6 data sets I used. These are the results I got, sir. And now I'm combining my two methods. One is
Okay.
that
Show the
future
result.
select.
Show the
Yes, sir.
result after combining.
Yes,
Yeah. Show the result.
Future. Yes, sir. These are the results.
Okay.
So first I used to take only 2000 documents. So for 2000 documents, if I applied the KNN algorithm in TF IEF method, this is the results, sir. So my proposed method, I got these results 0.755. So like that, I increased in every step. I increased 2000 record 2000 documents in step by step, and I stopped at 8000 documents. Why? Because if I go beyond 8000, above 8000, the value is not changing, and there is no change in my result. So that is why I stopped only. I took up to 8000 documents only, sir.
Okay. So what is
So
the best
this is
result in
for,
this table?
sorry, sir.
What is the best result in this table?
Here, if you observe in this random forest,
No.
If I apply the random forest at 8000 documents, I
Okay.
got
Just okay. Conclude. Next.
0. This is for FN dataset, sir, and
Okay,
this is for IMDb dataset. And
Okay. Next.
So this is a summary, sir.
Okay. Right.
The future scope is it will plan to propose a new vector representation, sir, for documents, and we can also implement. Instead of using this machine learning technique, I want to implement a deep learning technique to identify the.
Okay, Ravikumar, very good work. Actually, it is worth a journal. Actually, just try to extend and further you try to publish in a good journal also. Extended work.
Yes, sir. Thank you.
But only thing is you need to take care of the presentation time in a conference. You need to follow the timings.
Yes, sir. Yes, sir.
Okay, right.
Okay, thank you, sir.
Next, 52, 46. Are you there? 46. Sharma, A. Sharma, and 52. Paper ID 52, 57. Anyone? 52, 57, 60. Anyone? Please respond. Or else any other persons are there? Instead of
Yeah,
these
paper ID
numbers, these
70.
50?
70.
70. 70
Yeah.
is not in that part, not in this session. That is one more session. Just check it.
Hi, sir. I am Avanish, paper number 7, sir. I would like to give a PPT on music
sir.
journal classification.
Okay, Dakshyani Himabindu.
Yes, sir.
Paper ID 7, right?
Yes, sir.
Okay, share your PPT. Ravikumar, sir, I think this is paper ID 7, sir.
Okay, paper ID 7.
Yes,
yes,
sir.
sir.
Yes,
No, I think they are late. Actually, we need to first finish the existing, papers, sir, actually.
Remaining, no one is responding, sir. Remaining.
Okay.
Anybody is there?
responding?
Remaining numbers? 60, 57, 52, 47.
First you call, sir. If no one is responding, then you can allow
No one
them.
is responding. So that is the reason I allowed this person, sir.
Sure, sir. Okay, let them come.
Okay, paper ID 7. You can share
Yes,
our
sir.
screen.
Yes, sir. Can you see it, sir?
Yeah, okay.
Good evening, sir. I am Avanish, and I'm going to give a PPT on music journal classification, sir. And these are my teammates, sir. And my abstract is generally people carry their favorite songs on their smartphone, sir. songs can be of various genres, sir. The objective of our algorithm is that music classification is to make the selection of the songs quick and less cumbersome, sir. If one has to automatically classify the song or music, one has to listen to the whole lot of songs, and then select the genre, sir. It is nothing but like, sir, to, to select our favorite song, we need to search all the songs, and we need to take that song and keep it in our smartphone, sir. And it is nothing but like our makes it simpler, sir. That nothing is like, it is nothing but, sir, our algorithm takes some input like some data from the user, and it runs and takes all the songs based on that genre from the internet and makes it simple to the user, sir. Introduction, sir. A music genre classifier is a software program that predicts the genre of a piece of music in audio format. These devices are used for tasks such as automatically tagging music for distributors such as Spotify and Billboard, appropriate background music for events. The idea behind the project is to see how to handle such files in Python, compute sound and audio features from them, run machine learning algorithms on them, and see the results. Literature reviews are the groundbreaking work of Denenberg et al. Based on naive Bayesian and neural network approaches identifies 1 out of 4 styles of music improvisation. They were testing a performer's ability to consistently produce intentional and different styles. A database was elaborated to train the classifiers, and an accuracy of 98 was achieved when classifying among 4 styles. When using 8 classifiers trained to return yes or no for 8 different styles, they got all overall of 77 to 90%, sir. Etsy and Robert proposed 2 methods. They divided the music pieces into frames and got MFCs from average spectral engines. Finally, for comparison purpose, they used Gaussian mixture models, obtained a maximum of 99% recognition. Elizabeth published a paper, Comparison of
Okay,
Music
go to the
Journal
next
Class.
slide. Go to the
Okay.
next slide.
Problem definition, sir. Music plays a very important role in living people's lives. Music brings
Okay,
like-minded people.
tell me about the data set.
Okay, sir. And it is the outcome of our project, sir. Accuracy.
Okay, what
And
is
we
your
used
data set?
and we used this is the reference, sir.
Just what is your data set?
The musics are musics of a person who listens some part of music which
Okay,
the
just
person likes.
show me the data set. From where did you download? See, generally you will use a standard data set.
Yes, sir.
What is
From
the
Kaggle,
standard?
sir.
Hmm?
Kaggle, sir. I
Where did
downloaded
you
from
mention that? Where did you mention the source of the data set? You have to mention the source of the data set.
Okay, sir. And this is the accuracy of our model, sir. And we
Okay.
used conventional neural networks as our algorithm, sir.
Not conventional, convolution.
Neural network, sir.
Okay. Okay, fine. You're just reading the slides. Actually, you need to prepare well and come for the presentation.
Okay, sir.
Okay. Okay, conclude.
Thank you, sir. Thank you for giving me this opportunity.
Okay, fine.
Thank you, sir.
Any other paper? Any other persons are still waiting? "47, 46, 52, 57, 60. Anybody is there? Jatin Kalyanam, Manjula Srinivas, and Santhosh. Santhosh, your paper ID? I think you are waiting for the presentation, right? Manjula Srinivas.
No, sir, no. I just joined this group. No, my presentation is tomorrow, sir.
Oh, okay, okay. Any other? Santhosh?
Sir, Srinivas sir,
Sir.
we shall do one thing. Once you just call, because the scheduled time we cannot close ahead, but we'll just confirm whether they are presenting or not. The paper ID 52, 57, and 60.
Okay.
Just call and confirm. If they want to present, let them come. Otherwise, we will close it.
Sure, sir.
52, 57, and I think you have the mobile numbers with you. Nisheeth Joshi, Santhosh, and Mohan Mahanty.
Okay.
Because we cannot wait unknowing, like we don't know whether they will come or not. We will just call and confirm. If they are not coming, well and good. If they are coming, let them come. Because the scheduled time is still there.
Sir, I think 52. 52 paper ID. Ready to join, sir. The particular person replied.
Okay.
Sir, good evening, sir. Nagesh, sir. Welcome to the session, sir.
Yeah, good evening. Thank you.
So can you hear me? Nisheeth Joshi, I think your paper ID is 52, right?
Yes, sir, it's 52.
Okay, share your screen, sir.
Srinivas sir, meanwhile you can call the next person whether he will be joining or not.
Okay, sir.
Nisheeth sir, you can start your presentation.
Is it visible now? Hello, is it visible?
Yeah. Sir.
Yes, sir, it is visible. You can start.
Yeah. So in this paper we have shown the development of a part of speech tagger. Now, part of speech tagging has been the holy grail in a lot of NLP tasks, like part of speech tagging, machine translation, speech recognition, and other areas as well. It is also one of the basic steps while doing name entity recognition. Now, part of speech taggers have been developed for a lot of different languages across the globe and in India as well. But there are still certain languages which are still deprived of these basic linguistic resources. So Sindhi is one of the language which is very NLP deficient right now. Like before partition, people from the Sindh region, which is now in Pakistan, they used to live there and they migrated in 1947. So what happened was that people who are still living in Pakistan, the Sindhi people, they use Perso-Arabic script. And since Sindhi is one of the major languages of the Sindh province in Pakistan, it is being prominently developed. NLP resources over there are being prominently developed. But for Indian language, Indian context, we support the government of India. It supports Perso-Arabic script as well as Devanagari script. But we have a lot of Perso-Arabic tools because of because it is being developed in Pakistan. But for Devanagari script, nothing is available as such. So our attempt was to develop the POS tagger in a Devanagari script using LSTM model with pre-trained embedding. We used Globe for this. So POS tagging is something which is the most basic task in natural language. If we want to do any hybrid, if we want to develop any hybrid approach or a rule-based approach, we need a POS tagger, because iteratively we build the output. We build the NLP tools using the output that we receive from part of speech tagger. So across India, a lot of work has been done. Like in 2007, Asif Iqbal, he developed a Bengali-based POS tagger using conditional random fields. Then Hassan, they developed a POS tagger using a bigram, a trigram, and an HMM approach for 3 different languages. These were Telugu, Hindi, and Bangla. Then Singh developed a POS tagger for Turin Singh. He developed a POS tagger for Manipuri. Then there have been some development, like Sharma. He developed they developed a POS tagger for Punjabi in Gurmukhi script. Then Turin Singh, he again developed a POS tagger for Marathi using certain statistical approaches like HMM, CRF, and other approaches. Then Sunita developed a POS tagger for Malayalam. Parth Parke, he developed a POS tagger for Mizo. Now Mizo is not a constitutional language per se, but then Mizo is the main language that is being spoken in Mizoram by the people of Mizoram. So we need to develop tools for Mizo as well. So Parke developed a POS tagger for Mizo. Then Behra developed a POS tagger for Odia. Interestingly, Odia is one of the classical languages, one of the 5 classical languages, one of the 6 classical languages that we have. But still, there is a very less development, very less NLP resources have been developed for Odia. Then, as far as Sindhi is developed, Meher and Menon, they were the front runners in developing Sindhi POS tagger for Perso-Arabic script. Then, few years back, there was one student at IIIT Hyderabad. I believe his name was Rajiv Motlani. So he developed, for his MS thesis, he developed POS tagger in Devanagari script for Sindhi in CRF. Then we also started working on it. So we first wanted a POS tagged corpus. Since we did not have it, so we developed it as well. So we developed a Sindhi-based POS tagger for using HRM and CRF. Now this paper is kind of an addition, an add-on to our work that we have recently done. So while developing a POS tagger, we need a POS tag set. We need a labeling mechanism for the POS taggers. So generally in India, what we do is we use a standard POS tag set that has been developed by MIT, and it has been named as BIS POS tag set. And generally, these are the 40 POS tags that we have in a BIS POS tag set. But as far as I know, my understanding goes, I don't think that a Sindhi POS tag set was developed. So what we did was we used the generic POS tag set that was defined in the document developed available at on MIT's website, and we used the generic POS tag to tag our Sindhi corpus. So these were 40 tags that we used. These were nouns. Now nouns were of 5 different categories. These were proper nouns, common nouns, locative nouns, and verbal nouns, and so on and so forth. These were the 40 categories that we had. Now, for training our our system, we needed a corpus, a training data. So we had 30,000 sentences, which were manually tagged using these 40 different categories. So in all, we had 3,11,776 words. Among them, nouns were the highest. Now, again, nouns, among them, common nouns and proper nouns were the highest, and eco words and UNKs were the lowest in the corpus. We used a bidirectional long short-term memory (LSTM) approach, where we start with a H1 layer for a forward layer, and then we pass on like initially this is 0, and then we pass on its value, and we take the word that we have and we try to tag it. We try to provide a tag for it. Similarly, for a bidirectional, for a backward layer, what we do is we take we took the last the last word and provide the input from the hidden layer was 0, and then it will try to tag something. Now, this is the general approach that is being used by any LSTM POS tagger. What we did was that we also did word embeddings. We tried to generate embeddings for the input word that we had. So in order to generate word embeddings, we used Glove, and using this Glove toolkit that was developed by Stanford, we trained our Sindhi Glove system for around, I think, 110,000 some sentences, and so every input sentence that was given, it was first passed to the embedding layer, and then it was converted into vectors, and those vectors were passed into the LSTM layers, to the hidden layers, from which they provided us with the tags. So the model we had tokens, we had embedding layers. So these tokens were passed to the embeddings. So we had embeddings for like 300 vector embeddings for all the words that we had. And then we gave it to a forward and a backward layer. So forward layer, this is the equation for the forward layer, and this is what we had for the backward layer. So once we got the output, this was y hat. Now this is simple neural networks now. So we compared it with the actual values, and then we tried to find out the error, and then rearrange the weights, and again kept on doing this for until unless we did not got the correct answers, somewhat near to correct answers. Now, at this one particular juncture, there comes a problem of overfitting. The model becomes tries to overfit and tries to overlearn everything. So in order to avoid it, we added a dropout layer so that overfitting problem should not occur in our system. So for evaluating our system, we took out of those 30,000 sentences, we took 1,000 sentences from the training corpus, and we generated again 1,000 sentences, a fresh 1,000 sentences, and asked our human annotator to manually tag them. Now, these 1,000 sentences had 12,973 words, whereas an unseen corpus had 13,159 words. We use the accuracy measure to evaluate the performance of the system. So this was the correctly tagged lexicons. The correctly tagged lexicons are the lexicons where the human is saying that this is a noun, and the system is also given that it is a noun. So this is what we mean by correctly tagged sentences upon the total number of words that we have, total number of lexicons that we have. So suppose out of 1,000, we got, let's say, around 789 correct lexicons. So this was 789 upon 1,000. So this will give us certain accuracy. So the dynamics of the tagging was that we compared the results with our previous tagger that we had trained, the HMM tagger. So out of these 12,973 different words, 11,146 were correctly tagged by HMM, and 12,652 were correctly tagged by LSTM. These were the incorrectly tagged sentences. Out of the unseen ones, the 13,159 different words. 10,243 were correctly tagged by HMM and 12,473 correctly tagged by LSTM. So out of the total, this was what the HMM, our previous study gave, and this was the improvement that we had in our in this current study. So as far as the accuracy is concerned, I can say that HMM gave 81.85% accuracy for the overall corpus, seen unseen, whereas the accuracy of the LSTM was 96.15%. This was a very significant improvement over the previous approach. For a seen corpus, HMM gave 85% accuracy, whereas LSTM gave 97% accuracy. For an unseen corpus, HMM's accuracy dropped to 77%, whereas it was somewhere in 90s only, 94.79%. So this is how we developed our LSTM corpus, our POS tagger using LSTM. So and one significant improvement over previous approaches was that we used a word embedding approach as well. And since Sindhi Devanagari is a very, very resource poor language, our focus was on Sindhi Devanagari script. We used 30,000 sentences to tag our sentences, which were manually tagged by human annotators, and we used around 1 lakh sentences for training the globe word embeddings for 300 word vectors. We compared the result with our previous HMM based POS tagger, and we saw a significant improvement in this current approach. So correctly tags was 97.53% on seen corpus and 94.79% for unseen corpus, and the overall accuracy was around 96.15%. This is all to it. In case if there are any questions, then please ask them. Thank you.
Okay, Nitish sir, just do you have any information on number of epochs and training times, training and testing time frames compared to different algorithms?
So we used around we did our experiments for 50 epochs, 100 epochs, 150 epochs, and 200 epochs. These were the results for 200 epochs, and time was like training time was one of the constraints. But then when the system was trained, the output you can get within a second.
Okay, sir.
Any other queries?
Thank you, sir. Yeah.
Thank you. Thank you. Yeah.
Next, paper ID 52, Santhosh.
57, right?
57.
So Akshay will be presenting the paper, one of my authors. Akshay, can you share your screen?
Yes,
Okay,
sure. Hi, sir. First of all, hi. Hope you both are doing good.
Just share your screen.
Okay, sir. Is my screen visible, sir?
Yes, sir.
Okay. First of all, documentation to arthroplasty patients using Pearson correlation and Shapreville test. First of all, I give you an outline about what opioid is. Opioid is nothing but a common name for all the medical drugs that are used in today's medical field. Example, formalin, morphine, etc. So here, what we have done is we are classifying the patients as high risk and no risk. The basic of what how we are classifying the patient as risk and no risk is when a doctor prescribes opioid for a patient who has undergone arthroplasty, that is knee surgery. This is for particularly for knee surgery. We have considered knee surgery. So when they take opioids, that is drugs, so after 2 weeks, they'll have certain changes in their body, and we'll consider those changes. So if the patient is having a disorder, or if he's feeling uncomfortable, or if he's feeling some sort of discomfort, we consider that patient as high risk patient. And if the patient is not relieved from the pain, or he is having no difference in the pain, we'll consider him as a no risk patient, and thus the doctor can uh, uh, prescribe the medicine appropriately. So I'll just give an overview of what we have done. First, let us go through the abstract. As I said, opioid abuse, overdose, and drug addiction have become public health issues as a result of sharp increase in both prescribed and over-the-counter opioid use. So the pattern of opioid use for each patient should be considered in order to reduce overprescribing and overdoses. We consider the common problems of feature selection and prediction in medical data sets. Firstly, the importance of feature were ranked by the Shaprov-Wilk algorithm, and Pearson correlation between features were analyzed. Next, as I said, opioids are nothing but a group of drugs. So prescription opioids like fentanyl and heroin are all members of pharmacological class known as opioid, which is used to treat pain. So they are painkillers normally, like antibiotics. So doctors can prescribe prescription opioids, including oxycodone, hydrocodone, codeine, and morphine to relieve acute or chronic pain. The prescription of opioids approach should be customized to each patient's unique needs and modified depending on type of procedure being performed. Yes, the prescription may differ from each patient. So each patient will have their own necessity. Like if the pain is not relieved, the patient will require more amount or more ml of opioid. If they are relieved of the pain, they can gradually decrease the ml of opioid that they are using. So the existing system, let us look into the existing system. The misuse and overdose are highly related to opioid overprescription for chronic and acute pain treatment, where a one-size-fits-all prescription plan is often adopted, but can lead to substantial leftovers for patients who only consume a few. To reduce overprescription and opioid overdose, each patient's opioid usage pattern should be taken into account. As opioids are often prescribed for patients after total joint replacement surgeries, this study introduces a machine learning model to predict each patient's opioid usage level in the first 2 weeks after discharge. So let us look into the disadvantages of the existing system. It is easy to configure and use, and because it is effective at selecting those features in a training dataset that are more or most relevant in predicting the target variable. Classification predicts the class of selected data points, and also regression models supply a function describing the relationship between one independent variables and the response dependent or target variable. This is the system flow diagram. We are taking data set from the Massachusetts all claim data sets, and here that data set will contain the pharmacy claim and medical claim of the patient. So what we'll do, we'll consider the opioid prescription that is prescribed for the patient, and the prescription opioid is to be included in the study. Next, the patient category is patient with back pain and knee injury, that is hip arthroplasty or knee arthroplasty. If it is surgical or bone fracture, we'll consider both, and other pain, and also the clinical history of the patient is considered. So the point of preliminary was to set up, now the proposed system is the point of preliminary was to set up whether early organization of ibuprofen, heparin, both or neither, impacted the clinical course of intense knee replacement. RFECV, that is recursive function elimination, with SVM performed a recursive function elimination in a cross-approval circle to locate the ideal number of highlights. The incorporated artificial intelligence approach of RFECV with SVM utilized in the examination received straight as its assessor separately. In this examination, a recursive feature elimination calculation was completed with program tuning of the quantity of highlights chose with cross approval. Advantages. It is easy to configure and use, and because it is effective at selecting those features in a training dataset that are more or most relevant in predicting the target variable. Classification predicts the class of selected data points. Regression model supplies a function describing the relation between one or more independent variables and the response dependent or arbitrary. These are the papers that we referred during the period project. So first project paper was pre-operative and post-operative opioid use by order classification. Here we investigated the use. We came to know about the investigation of the use of opioid medication in a pre-operative and post-operative patient undergoing primarily total joint arthroplasty. And here the publication was done by Bradley J. Zarling and Sanar S. Yokana, MD, and Darren T. And the next paper is risk factors for persistent and new chronic opioid use in patients undergoing total hip arthroplasty, a retrospective cohort study. Here, what we learned was determining chronic opioid use pre-total hip arthroplasty and post-total hip arthroplasty, and risk factors for persistent or new chronic opioid use post-total hip arthroplasty. Next paper is reasons for pre-opioid opioid.
Come to the results.
Associated. Okay, sure. This is the conclusion, and we have included the sample screenshots of.
Do you have any tables? Do you have any tables?
Work.
Do you have any tables in the results?
No, only screenshots of all.
No, sir, we have not included any tables. We have included only sample screenshots of. No, sir.
Okay. In any presentation, you should include tables, whatever result analysis that you have done. You have to put it in a tabular form.
Okay, sir. Yes, I can understand, sir.
Okay, thank you.
Thank you, sir.
Thanks.
So that's it, sir. Remaining paper ID 46 and 60. I think that today they will not give the presentation, sir. Maybe tomorrow. I called number of times, sir. 46, I think some personal issue. The particular person doesn't in the today's session, sir. 60
Okay,
not
sir.
responding, sir.
You just give them only based on genuine reasons. You give them permission, sir. If they have requested you, otherwise you leave them.
Okay, sir. 60 absent, sir. 46 has taken the permission, sir.
Yeah.
Tomorrow, I think the particular person
Please
will
allow
give
them only if they have requested with any genuine reason. If they did not take permission for today, don't allow them for tomorrow.
Okay. Okay.
Sir, I think everybody else, all the. I think for today we can close this session, sir.
Today we are going to close, sir. Thank you, sir.
Both
Thank you for
are
your.
asked to actually take the screenshots of I think each and every presentation. If you have recorded the session, then from that also you can take.
Yes, sir. Already I have taken the 3 screenshots and everything is recorded also, sir. No problem, sir.
Okay, okay.
Thank you, sir.
Srinivasa Rao Garu. Very good coordination.
Thank you, sir.
So we shall meet tomorrow evening again. Huh?
Okay, sir. Same time, sir. 6:30. I will give I will send a link, sir.
Okay.
Thank you, sir. Thanks for your time, sir.
Thank
for
you.
Supporting. Thank you, sir.
Thank you, sir. Bye.
Thank you, sir.
All of you can leave the meeting now.
Thank you, everyone.